Today's lesson is going to be about how to graph the tangent function. So just like sine and cosine, we have a tangent function. Y equals tangent of x is the parent function. The tangent function is a little bit different. It has some different characteristics. Even though it is a trig function, it looks very different than the sine function or the cosine function. The tangent function, if you remember what tangent is equal to sine divided by cosine. So we're actually going to use sine and cosine to figure out what the tangent function looks like, but they do not look anything alike. So a couple things that we need to know about the tangent function. The function tangent has a period of pi instead of 2 pi like sine and cosine does. So that's going to be something very important because it's going to play into the period and later on when we calculate how to find or use the b value to calculate the tangent or the period. So whenever we have the tangent function, we're going to have asymptotes because tangent is undefined in certain places. So what we need to figure out is where is tangent undefined at? And if you remember, tangent is sine over cosine. So essentially where cosine is 0, the tangent line is the tangent curve is going to be undefined. So if we look at the unit circle, where would tangent be 0 at? Well, if you look straight up, remember tangent is the x value in each one of these ordered pairs. So the only place that tangent or cosine would be 0 would be at 90 degrees or 180 degrees. So we know that it's 90 degrees or pi over 2. Okay, and then it would also be 180 degrees or pi. So what that means is tangent is undefined at 90 degrees, 180 degrees, and it's actually going to be or that's not correct, that's not 180 degrees, that's 270 degrees. Wow, glad I caught that. 270 degrees, or 3 pi over 2. Okay, so 90 degrees, 270, which is 3 pi over 2, and basically every 180 degrees it's going to have a asymptote. Why? Because 90 degrees is straight up, 270 is straight down, and if you keep rotating around this circle over and over and over again, every time you get to a 90-degree coterminal angle, you would have an asymptote, and then you'd have an asymptote at 270's coterminal angles, and then so on and so forth. So what happens is every 180 degrees, you would have a asymptote. So you can also write it something like this, pi over 2 plus pi k, kind of like what we did when we solved equations with the basic trig functions. To find all the angles, you have to do the plus 360k. Here you have to do the plus pi k because that's how far they are apart, pi radians. Okay. Thus, the graph of y equals tangent x will have vertical asymptote at each undefined value. So you're going to have asymptotes at pi over 2 plus pi k. And that takes care of all of them. So that'd be 90, 270, 450, so on and so forth. You would also have negative 90, negative 270, so on and so forth, which would take care of all of those. Okay. Now, here is one that is a little different from the sine curve. Notice this, the period equation is pi divided by b. Okay. In a sine and cosine curve, it's 2 pi divided by b. In tangent, it's pi divided by b because the period is shorter. So the period is pi, so it's pi divided by b instead of 2 pi divided by b. All right, so let's look at what the actual tangent curve looks like. So what we're going to do is we're going to talk about what y equals sine over cosine would look like. Okay, because we know a lot about sine and cosine. Well, if you think about what the sine curve looks like, sine curve looks like this, and the cosine curve starts in the clouds and looks like this. Okay, so what I want to do is I want to first label my x-axis as pi over 2, pi, 3 pi over 2, 2 pi. Then you can go back here, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So what do? So let's start off by looking at 90 degrees. Well, 90 degrees, if I look at sine of 90 is right there. Cosine of 90 would be right there at that point. So that's going to be 1 divided by 0, which is undefined. If something is undefined, that means it's going to have a vertical asymptote graphically. So what I do is I put a dotted line right there. Okay. make it a little bit better, make it a straight line. So there's a vertical asymptote at pi over 2. Okay? So then what we're going to do is we're going to look at 180 degrees. Well, 180 degrees for sine would be right there. 180 degrees for cosine would be right there. Well, 0 divided by -1 would be 0. That's a point. We can graph that. Well, then if we look at 3 pi over 2, that would be right there. That would be right there. This is sine. This first graph on the left is sine. So that's -1 divided by 0. -1 divided by 0 is a undefined value, which means I'm going to have a vertical asymptote right there. And then you'd have 2 pi. Well, 2 pi would be right there. 2 pi would be right there, which would be 0 divided by 1, which is a point that looks like that. If we go back here to 0, what does 0 look like? 0 would be right there for sine. 0 would be right there for cosine. So that would be 0 divided by 1, which would be 0. And then if I continue out this pattern, notice every 180 degrees, I have a asymptote. So I'm going to have an asymptote here. And then I'm going to have an asymptote here. And then I'm going to have an asymptote here. And then I'd have an asymptote here. And so it just follows this pattern. So notice you have an asymptote, then you have a point 0. You have an asymptote, then you have a point 0. You have an asymptote, point 0. Asymptote, point 0. Asymptote, point 0. And it just follows this pattern over and over and over and over and over and over and over again. Now, that doesn't really give us a whole lot of what the graph looks like. Okay? So then what you can do is you can pick a number that's really close to this asymptote. So this asymptote is at 90 degrees. So what if I looked at sine of 89 and cosine of 89? Well, 89 would be just short of that one, and it would be just short of that one. Well, if I take that, 89, well, let's say that that ratio instead of 1 is something really close to 1, 9 over 10. So that I'm just guessing that. It's not perfect. Okay? I'm just saying that it's 9 over 10 because it's going to be really close to 1. Well, on cosine over here, that cosine is going to be really close to 0. So I'm just going to pick out a number that's really close to 0. 1/10 is pretty close to 0. If you bracket that, what happens is you get 9 times 10, which is 9 times 10, over 1 times 10, which is 1 times 10. What happens is the 10s cancel and we're left with 9. So what happens is when my angle is really close to 90 degrees, I'm going to be way up here at 9. And we know from asymptotes from earlier in the year, when our graphs get really close to asymptotes, they follow them off to infinity. So what happens is this graph actually looks something like this. And then what happens is it comes over here, and it follows that one downwards. So then these graphs just repeat themselves. And it looks like this over and over again. Okay, and you can go backwards and do this one. And so this is the parent function, right? You do that over and over and over and over and over again. So what that says is from negative pi over 2 to pi over 2 would be one complete cycle. We get the negative ratios on the left side, we get the positive ratios on the right side, we get 0, and that's why we have the period is only pi, because from negative pi over 2 to pi over 2 is a distance of pi. So let's look at one of these. So we're going to do the exact same thing we did with a sine or cosine curve. We're going to start off by listing A. A is -2. B. B is 3. C is -pi. D is +1. So then I'm going to look for the period. The period is pi divided by B, which in this case is 3. I'm going to then have to find the phase shift, which is still -c over B, so it's double negative over B, which is 3. The vertical shift is still just D, and the interval length is the period divided by 2 this time, because there's only 2 intervals. So it's the period, the interval length is the period divided by 2, which in this case is going to be pi over 3 divided by 2, which ends up being pi over 6 when you bracket it. Okay, so just like when we did it before, we're going to start with our phase shifts. We're going to go to the right, pi over 3. There's my phase shift. My vertical shift is up 1, and so I'm going to put a horizontal line in there. If you want to put a vertical line in for your phase shift, you're more than welcome to do that. It's not necessary. I don't usually do it, but some students like to do that if they want to. So there's my phase shift. There's my vertical shift taken care of. Now I'm going to do my interval length. I'm going to take and I'm going to add pi over 3. So my starting position, pi over 3. And I'm going to add my interval length, which is pi over 6. So this phase shift right here, that's my ordered pair 0, 0, my starting point. That's the middle point. When I go one interval to the right, that is going to be my vertical asymptote. One interval to the left would be my vertical asymptote. Okay, so I have those things. So I have to add interval length pi over 6. I need to get common denominator, so I'd make this 2 over 6, multiply everything by 2. 2 pi over 6 plus pi over 6 would be 3 pi over 6, which reduces to pi over 2. So this point right here would be pi over 2. Then I'm going to subtract, because I got to go to the left, because I got to find where that left asymptote is. Subtract that. 2 minus 1 would be 1 pi over 6. So what I can do is I can come in here and put in my asymptotes. My asymptotes are at the 90 degrees and the pi over 6 degrees. And so that's what my graph would look like. So then what do I make the graph? How do I draw the graph? The negative reflects it over the x-axis. So typically as it goes to the right, it goes up. But now since it's reflected as it goes to the right, it's going to go down on the asymptote. And then this one is going to go up. The -2 just says it's going to be a little bit taller than normal. Whenever we're doing that, it's not going to have a huge impact on what we're doing. So I wouldn't spend a whole lot of time of getting that 2 correct. It just means it's going to be a vertical stretch, which means it's taller than a normal function. The negative is what's the most important thing. The negative reflects it over the x-axis. If you wanted to draw another one, what you would do is this right here. You would add pi over 6 from pi over 2, which would be 4 pi over 6 or 2 pi over 3. Now, how did I do that so fast? Because I still have the 3 pi over 6 here, plus pi over 6 would be 4 over 6, which reduces to 2 over 3. And then take 4 over 6, add another pi over 6, which would be 5 pi over 6. And then that would be my vertical asymptote. And then I draw my vertical asymptote in there. And then I make another. And don't forget, the ordered pair is right there, not down here on the x-axis like I put it, because we vertically shifted it up. And then you just keep making those same marks over and over and over again, and that is the tangent curve.